Hey, it's Tony from Adafruit, and this video I'm going to look at how to blink an LED with MicroPython. So this is like the hello world of hardware where you just get a basic LED to turn on and off, really easy and simple, but a good process for a beginner to go through to kind of learn about how to connect components, and then more importantly with MicroPython, how to control a digital input or output, so how to set an LED on and off. And so we'll just kind of walk through how to wire up an LED to a MicroPython board and then how to write the code that controls that LED. And the cool thing with MicroPython is that it's a little bit simpler to do something like this because it has that interactive terminal. So you can go and connect to it and just start running Python code. So you really don't have to learn a lot about like what functions are and what's a setup and a loop and things like that. So we'll kind of just dive in and see how this works. And if you're totally new to MicroPython, when this video goes up on YouTube, look in the description. I'll put a link to a guide that I did that has a video that goes with it that explains like what is MicroPython, and then another one that talks about how to load MicroPython onto a development board. So there are a bunch of different boards you can get. You do need a board that's running MicroPython for this. So let's just kind of dive in. We'll jump to the main view and look at, actually, surprise, surprise, another guide that I have. So this is a guide on how to blink an LED with MicroPython. We're basically just going to run through this in this video, and I'll show you all the steps and things that you need to do. And it'll be pretty simple and straightforward. So in the upper right, I've got all the parts here, and we'll just wire this up real fast. What you need to build this, and we'll go to the hardware page here real quick too. So it just mentions you need a board running MicroPython. Go to this guide that mentions how to load MicroPython onto a board, because some boards you can buy, they come with MicroPython burned onto it already and running it. Some boards like the ESP8266 you need to load yourself, and it's actually pretty straightforward. So I have a little video even that shows you how to load it up on some of those boards. Now for this example, I'm going to use the Feather Huzzah ESP8266. So real nice, easy to use board that all the tutorials kind of mention and link to. So if you don't know which board to get, this is a good one to start with. It's kind of low cost, but still really capable, and the MicroPython support is excellent for it. So check that out. Now the other thing you need an LED, obviously. Some of these boards have LEDs built in. So the Feather Huzzah has a little LED right here in front of my finger, and that's connected to digital input number 0. So this board has it, the Feather Huzzah. The older Huzzah Breakout that's not the Feather version and doesn't have like the USB to serial chip on it, that also has a little LED connected to pin 0. The Pi board has some LEDs, so I actually mentioned later in the guide like where those LEDs are. So if your board has an LED built in, you might be all set. You could use that LED. But if not, even if you do have an LED, it's kind of a good learning exercise just to go through and see how to connect an LED, to really see that those digital inputs and outputs work. So I mentioned all the parts here. You need obviously an LED. So this is an LED right here. And don't get a fancy LED that's like an RGB LED or, a NeoPixel style, a digital addressable one. You want one like this that has just 2 leads. There's a positive and a negative, or a cathode and anode connected to it. So there's one lead that's a little bit longer. So any kind of LED like this, hopefully one that's in the visible light spectrum so you can see it. But you could use an infrared LED if you wanted. Maybe you have infrared vision. So this is for Geordie LaForge and I guess Predators or anyone else that's building some of these hardware projects. The next thing you'll need is a resistor. So anytime you wire up an LED, you generally need a resistor to limit the current through it. That prevents the LED from burning out because, if you just connect the LED from a digital input like down to ground, it's just going to send as much current as possible from the board, which could damage the board, could damage the LED. So throw a resistor in there and that limits the current. The exact value of the resistor doesn't really matter for this. I mentioned anything from like 560 ohms to like 3 kilo ohms. Something in that range should be okay. If it's a little bit less or a little bit more, it's probably okay. The lower the resistance, the higher the current, so like the brighter the LED will be. So, just be careful, like don't use like, I don't know, a 50 ohm resistor or something. That might be a little too much current for your boards. And if you really want to be specific, you should probably look up for your board what's the maximum current that it can source. Most Arduino type boards, I think they can source at least like 20 milliamps or so, but don't quote me on that. Generally you should be okay though, 560 to 3 kilo ohms. And if you're really unsure, err on the side of like a larger resistor, like a 2.2 kilo ohm or something. But you do need that resistor, like I said. Don't skip it. You do want the resistor. And then you need a little breadboard, this guy right here, and then some jumper wires, so things to connect components. And I mentioned in the guide, if you've never done any electronic stuff, check out some of these guides here, like that talk about what a breadboard is, how to use it. So I have the feather huzzah actually connected to this breadboard already. You know, it just pushes down into here. You can see kind of there's some headers in here. I'm not going to pull it out totally right now because it takes a little bit of force to get it out. But basically, it's on this breadboard, and then I can hook up wires to the holes on the sides here, and it's just like as if I connected those wires to the little pins and things that are soldered onto there. So that's what we're going to do. We're going to start by just wiring it up. So I mentioned in here, super simple schematic. You know, you basically just wire one lead of the LED. There's a longer lead of the LED. This is the anode, and it's hard to tell with this LED because they're a little bit short, but you can kind of see this right one here is a little bit longer. So that's the positive side of the LED, and the LED won't light up unless voltage comes in from this side and then leaves from this side, like down to ground, or through that resistor at least. So that's very important. So make sure you get the orientation correct. It's not the end of the world if you get it wrong. It's just your LED is never going to light up and you're going to wonder what's wrong and troubleshoot everything. And then the last thing you try is flipping around the LED and then it works. So trust me, been there, done that. But that's all we need to do is just wire up this LED resistor and a few things. So I'm just going to stick the LED into the breadboard right here. And then on the right side, I have the longer LED leg, the anode. So I'm going to connect that with the yellow wire to a digital input on the board. Now you can pick any digital input for your MicroPython board. I'm going to use number 15 for this board, but really anything could work. Just do be aware some of the inputs, at least on the ESP8266, not all of them can be used by digital inputs and outputs. Like I know pin number 16 you have to be careful about on the ESP8266. That's used when it like wakes up from sleep or something like that. So that one be careful about. I think all the rest are okay. Maybe 1 and 2 might be used for serial. If you go back, actually I have a link to documentation for each board. It calls out in the documentation for the ESP8266 on MicroPython which pins you can use and which ones you can't. 15 is a good one. 14, 13, 12, those are good ones too from what I've seen. So okay, so we'll use that one. And then the resistor I'm going to put in the breadboard here. So the resistor is going to connect to the shorter leg of the LED, the cathode. So that's kind of the negative leg. And then the other end of this I'm going to connect to the ground pin on the board. So let me make sure I get the right one. Okay, so there's the ground pin. And I'm just going to double check that I have the right pin 15 selected because the text is a little bit offset. Okay, yeah, I've got the right one there. All right, cool. So that's wired up. And that's all that you really need to do. Pretty simple and straightforward. And if you're using the onboard LED, you know, don't worry about it. You don't have to wire this up. And then, okay, so the next thing, let's jump to actually how to blink this thing. So, and like I mentioned at the top of this page here, if you're using like the Pi board, I called out which of the inputs you want for the onboard LEDs. Kind of neat. I didn't realize it has 4 LEDs. They're all different colors here, but you do have to use specific pin names. So like B4 and A15. And I also called out on the Pi board, when you use the pins, they usually have a string instead of a number. So if you want to light up the blue LED, you need to use pin quote B4 versus like other boards like the ESP that we're going to use. The pin numbers are actually numbers, so you can send like 0 or 15 or 1 or whatever for that. So just be aware if you're using Pi board, it's a little bit different. And again, the documentation for each board is going to call out usually how things work. And then the next step is, so we need to connect to the serial REPL, or the read, evaluate, print loop. That's basically the Python prompt that MicroPython gives you. Now I actually linked to a page in the How to Load MicroPython guide that talks through what you want to do. Some of the boards you have to load a special driver to access the serial REPL. So like the Feather Huzzah actually, the ESP8266 board that we're using right here. If you're on Windows or Mac OS X, you have to install a little Scilabs driver. So I've got a link right here. The Pi board needs a driver. BBC Microbit needs a driver on Windows. So just be aware, you probably have to install a driver. And then I mentioned here on Windows, you'll want to use a tool like PuTTY so that you can open up the COM port or the serial port and start talking to the Python REPL right here. Or on Linux or Mac OS X, you probably want to use the screen command that should be built in, or you could use your package manager to install that. But you know, get to a point where you've got MicroPython running on your board, you can connect to the REPL, you can print out hello world before you really dive into doing this. You know, make sure you can get the basics going. But then, okay, once you've got that, we'll just start connecting and we'll see what happens here. So I'm going to connect my board to my machine and I'll plug it in. And okay, so at this point now I'll switch to the command terminal and I'm just going to use the screen command to connect to my board. So on my Mac, it's dev tty.scilabs USB to UART and then 115200 baud. If you don't know the serial port for this, actually I'll show you real quick. On Mac, what you can do, and on Linux also, do a search, run the ls command dev tty.star, and this should actually show you all the serial devices. So you can see I have this Bluetooth device, which generally every Bluetooth Mac is going to have this. But if I unplug this board and then run this command again, now you see that Scilab's USB to UART goes away. So I know for sure that this slab USB to UART must be my MicroPython board. On Windows, you want to open Device Manager and then look under, it's I think the serial and LPT port node. There's a list of COM ports, and you'll see for this board at least there's like a Silicon Labs node under there. So look for that and then look for the COM port number. Usually like COM4 I think is kind of the default one that it gets, but it might be different depending on how many serial devices you have. So that's how you find that on your different operating systems there. But then okay, so we're going to connect again and I'm going to use screen. If you're on Windows, use PuTTY like I mentioned in the guide, and we go to dev tty.scilabs 115200. And then you load up the REPL and you might not see anything, but press enter and you hopefully get a little prompt like this. So you've got Python code you can type in here. If you press enter and nothing happens still, press Control-C. That will interrupt any program that's running just in case something was running on your board. But okay, so at this point now we're ready to go. So let's just see what the guide says. So we're going to start by importing machine. So we're going to run this command in the REPL. And what this does, this is just standard Python code. This imports a module called machine. And this is a module that's built into MicroPython. And I think it's meant to be kind of the hardware access layer. So it has your digital GPIO access, PWM, I2C. You can actually see if you run help on machine, it's going to print out everything inside this module. So you can see that there's functions in here like memory, reading and writing. You can change the frequency of the processor. That's kind of cool. I haven't really messed much with that. Be careful when you change frequency of the processor as you're running, because usually that might break a lot of code. You can see it has classes in here, so things to access like the real-time clock, timers, the pin class, which we're going to come back to. That actually lets you control the digital inputs and outputs. So that's really handy. And this help command is really useful and really cool that MicroPython implemented this. So in normal Python, if you run help, you get a really nice description. It uses the doc strings and things. It's not that nice in MicroPython just because, hey, this is running on a tiny little microcontroller, you know, what do you expect? But you can at least see, like, here are the functions and things that are in here, so that's pretty cool. And you can do this on anything. So if I run like help on machine.pin, this kind of shows you these are the functions on that pin class. So you can see it has like a low function, high function. You can't tell, unfortunately, what the parameters are. I don't think it tells you that. If I do like pin.init, let's see, does that give me anything? It just tells me the function, so you don't really know. But anyways, okay, so here's what we want to do next. Let's just keep following the steps here. We're going to create an LED object that's an instance of that machine.pin class. And so let's do that. So we'll do LED equals machine.pin. And then this takes two parameters. The first parameter is the pin name or number. And in my case, it's 15 because that's what I connected my LED to. And then it takes the type of pin. Is this an input or an output? And in this case, we want to make this an output because if you drive that output to a high level, that's going to send some voltage through the wire connected to the LED. The LED is going to turn on. And then if you set it to a low level, like basically 0 volts, that's not going to be enough voltage to turn on the LED, so it turns off. And so that's how we can blink that on and off. But a pin could be an input also. So if you have like a switch connected to one of these and you press that switch, you could read that as an input. And we'll look at that in later videos. You know, for now, we're just going to blink this LED, so we just need to do an output. And to tell that this is an output, you want to specify machine.pin.out. So that's just a constant that just says this is the type of pin that we're creating here. So we do that, and that creates our LED object. And then the next thing that we mention here is it's pretty easy. You just call the LED.high and LED.low functions. So if I wired everything up correctly, hopefully when I run LED.high, hey, look at that, the LED turns on. So that's all you need to do to turn it on, and then turn it off, LED.low, turns off. So that's pretty cool. Like, we've just connected to the board, run a few commands, and I'm blinking the LED myself here. It's one nice little tip. In the REPL, if you press up, you'll go to the previous command, and it has a history of like 10 commands or so. So really cool how polished they've made this MicroPython REPL. I gotta hand it to them that this is nice stuff. But if you just want to learn about how to blink an LED, this is it. Like, just you set this pin to a high logic level, and that's going to turn on the LED because we've wired it in such a way that when it gets enough voltage through there, it's going to go down to ground and then light up the LED for that. So that's pretty cool. Simple, let's see, only 17 minutes in, and I talk a lot, but even in that amount of time, we've gotten to blinking an LED. So that's pretty cool, and hopefully a little gratifying if you've never done hardware stuff. It's always fun to just see something turn on when you're actually running some code here. That's always fun. So okay, so that's cool. But let's do a little bit more advanced stuff. So it kind of sucks that I have to blink the LED myself. So remember, this is just Python code. Like, if I wanted to do something in a loop in Python, like print stuff out, you can do a for loop. So like for I in range of 10, let's say. So this is going to repeat whatever I do 10 times. If I just want to print hello world, okay, this is like Python 101. And then one little note. So notice how it's automatically indenting for me because it knows I started this for loop. So that's cool, like, way to go, MicroPython. But then to tell it that I'm done with this loop, I actually have to press backspace to remove this indent right here. And then I press enter, and it actually just goes through and runs the loop. So that's just if you start a loop or start some indented block of code, you have to make sure to end it. But okay, so that's simple Python loop. We can do that with hardware here too. So what I'm going to do, I'm going to import another module. I'll import the time module because this has a really handy function. And again, you can run help on this if you want. So you can see it has some sleep functions in here. So the sleep function is actually a standard Python function that takes a time in seconds and it'll sleep for that amount of time. There are other ones. There's a sleep in milliseconds and nanoseconds, or microseconds rather. But basically that amount of time is, or those sleep functions are just sleeping for a smaller amount of time. I think maybe they're a little more optimized than the Python sleep one, because the sleep one takes in a floating point value, which can be a little bit slower, but don't worry about all that stuff. Let's just use the sleep function. So we'll say time.sleep, and if I put like 2 in here, this is going to sleep for 2 seconds. So notice how the REPL kind of went away for 2 seconds. So it was running that sleep. It was doing nothing. So good to know, but I can sleep for a smaller amount of time, like 0.5. I'm going to sleep for half a second. So let's put this all in a loop. So for I in range of 10, this is like the Python syntax for making a loop that runs 10 times. But if you want, you could say 100 times or 1,000 or any number in here. And that's something that you actually try, like changing some of these values to see what happens. Okay, now in the loop, so I'll start off, because when I blink the LED, I want to turn it on. So we'll say LED.high. And then I want to delay for a little bit, because if I didn't put a delay here, I would just instantly turn it off. And MicroPython's going to run pretty fast, so you won't even see the LED basically changing. So we'll delay for a little bit. We'll say half a second. And then we'll say LED.load, turn it off. And then again, delay again so that you can see that it's off for a small period of time. And then I'll press backspace just to end this block. And I press enter, and hey, let's check this out. So the LED is blinking. And it should blink 10 times. And notice I can't do anything right now. I don't have the Python REPL anymore. So that's an important thing that we'll talk about in a second here. So, MicroPython, it can only really do one thing at a time. So it's for this loop that it's running, that's the thing it's doing. So it's going through 10 times, setting the LED high, which turns it on, sleeping for half a second, set the LED low, turn it off, sleep for another half a second. So it takes a full second to get through an iteration of the loop. And while it's doing that, it can't listen for the REPL. So, it can't listen for me to type in a new command like hello world or something like that. So it's just stopped the REPL, and it's running this block of code. So important distinction, just because, you might want to say like, all right, let's blink 1,000,000 times. And then you put that in, and then it's like, uh-oh, is my board locked up? Like, how do I actually go back and enter code? Or maybe I have to wait 1,000,000 seconds for it to finish there. So could be waiting a little while for that. Okay, let me show you something interesting. So let's put the board into an infinite loop, blinking the LED. So we'll use a while loop. And I've shown this before, but the syntax in Python, so if you want to do an infinite loop, just while true. And then inside of here, we'll do the exact same code, set the LED high, sleep for half a second, set the LED low, sleep for half a second, and then that's it for this loop, so I just backspace. And okay, cool, so now we're blinking forever, which is cool. The problem is, now how, like, when I'm done running this, what do I do? And like, I could even exit the serial console, you know, I exit the console, it's still gonna run, the code's there, and if I connect to the console, it's still running, and so like, you know, I'm pressing enter, I don't get anything. Here's the thing, press Control-C on your keyboard when you're connected to the REPL, and that sends an interrupt, or basically a keyboard interrupt that says, okay, stop running, and the whole program will basically exit. And sometimes you have to press Control-C a couple times, but that's one good thing to know. If you do get into an infinite loop or you're running something and you want to stop it, connect and press Control-C, and that should stop everything. So you know, you'll be all good here. Now you might be wondering, okay, what happens, like, let's put it back into a loop again. So we'll say while true, and we'll do LED dot high, time dot sleep 0.5 seconds, LED dot low, time dot sleep 0.5 seconds. You might have also noticed I didn't have to create that LED object again, because you know, once you create something in the REPL, it sticks around. And so I'm gonna press enter, and so now I'm doing this loop. And like I said, everything kind of sticks around. So like when you import a module, that's gonna stay imported as long as the board is powered up or it hasn't been reset yet. And so, you know, and just like running this code, it's gonna keep running this code forever as long as the board doesn't power down. But let's see what happens. If I unplug this, and I'm gonna disconnect from screen first, because sometimes I've noticed if you remove the power and you're connected with screen, it gets really confused. So close screen and then power down. But if I power this board down, you know, you might wonder, okay, what happens when I power this back up? So I'm gonna power it up, and we're not blinking anymore. So I can connect to the board, and you can see I'm just back at my main REPL. I don't even have that LED object anymore. So, you know, all that stuff is gone. So unfortunately, you know, this is not how you get code to run forever on the board, but it's a good just example of, you know, you can connect, start blinking the LED, and as long as it's powered up, it's going to keep doing that. Now, something I don't get into the guide, I just mentioned at the end of the guide that we're going to get into this later, but I'll show on this stream. I've actually been working on a little tool to simplify how you can actually put files onto a MicroPython board, and there's one special file that if you create, the board will actually run when it boots up. And so that's where, if you want to put code that always runs when a board powers up, you can put that into a file called main.py, and then put that on your MicroPython board, and then as soon as you apply power, it goes through a quick little boot process, and then it just starts running your main program. And maybe your main program is to blink an LED, for example. So I'll run through that, and I should just say, like, this is a little advanced. I'm going to actually do another live stream, hopefully on Monday, and have a new guide out that goes into more depth for this. But I just want to give a little preview, because some folks were kind of mentioning in the comments from last videos, you know, hey, how do you start running code that, you know, persists and acts like an Arduino in some ways, where, you know, you've got like a setup and a loop function for that. So let me show you what I've been kind of thinking about here. So I'll close out of the REPL here, and I'll link to this little tool here I call Ampy, the Adafruit MicroPython tool. And this is just a little tool that talks to a MicroPython board over its serial connection, and it lets you interact with a file system that's on the MicroPython board. So as far as I know, every MicroPython board has a little file system. Even if there is no like SD card, like on this ESP board, they just take a portion of the flash memory and just say, this is a file system. So it's a proper, I believe it's a FAT file system. So you can create directories and folders and files. And the really cool thing is, if you want to manipulate those files in your Python code, you use the normal Python functions like open and write and read. Exact same stuff you would do on your desktop works on MicroPython, which is really cool and powerful. We'll see this a lot more in the future. And, you know, big difference between something like Arduino, where, you know, Arduino, if you want to load a file, you probably need to add like an SD card potentially, and then use like the SD library, and it gets a little tricky. And then like, you know, if you wanted to put that into the flash memory of the Arduino, you've got to compile it in as like a progmem thing, and you know, it's not easy. Whereas with MicroPython, I really love how they've made this decision that everything has a file system, so you can write code that reads and writes files. Okay, so anyways, I'm not going to get too deep into how to use ampy because, like I said, there's a tutorial and a video that's going to come in the future very soon to explain this. But I've tried to make it work with both Python 2.7 and 3.0, which is always a pain, but it is possible. And I did also want to make it so it's a pip install. So if you just run like pip3, that's Python 3, or just even normal pip install Adafruit-ampy, that should give you everything you need to use this tool. Unfortunately, there's already a project called ampy on the Python package index. It's something else, I don't know what it is, but so hey, we've got Adafruit-ampy now. So let's do that. I'll run pip3 install Adafruit-ampy, and this should install, I've already got it installed, but this installs the tool. And then if you just run ampy-help, and make sure you run that because it creates a little command line tool that hopefully gets put into your path, and that gives you some options here. So it has a bunch of commands you can run, like you can use a get command to read files from a board, or ls to list the files on a board, put to put a file from your computer onto the board, rm, remove a file on the board, and run, which basically takes a script from your computer and runs it on the board here. And then everything takes in some parameters, so you have to tell it the port, basically the serial port name that you're going to use for this. So I'll just show you real quick. If I run ampy, we'll give it the port, which is dev.tty.scilabs for me. I don't have to give the baud rate because it knows that MicroPython boards default to 115200 baud, but if you want, you can specify a different baud if you need. And then let's just use the ls command. So I'll just use ls, and let's see what happens. So okay, so I ran this, and I had my board connected, and this is cool. It actually just showed me that there's a boot.py file on my board. So let's try another command, and I'll show you something cool. If you don't want to type this port all the time, because unfortunately it is required, you can actually set an environment variable, ampy_port, and set this to dev.tty.scilabs usb to uart. And then now I can run the ampy command, and if I leave out the port, it's just going to read from the environment variable how to do this. And I think I mentioned here for Windows, it's a different syntax. You have to use the set command. I haven't tried it yet, so hopefully it works. I'll get around to trying it before I do this other guide on this. Anyways, let's just get this file. So I can get boot.py. And if I wanted, I could save it locally as a different file. If I don't put anything here, it's just going to download it and print it out. So you can see here, this actually just downloaded that boot.py file from my MicroPython board and printed it out. And you can see this is just Python code inside of that boot.py. So it's this is some commented out debug stuff. You don't need to really understand what this stuff is, but I'm just showing you, like, this is some of the internals of MicroPython. But here's the cool thing with MicroPython. If you create a main.py file and put it on the root of your board, it will run that when your board starts up. So let's make a little main.py file here. I might have one already. Hey, look at this. I've pulled one out of the oven that I did ahead of time here. So this is exactly what we just did before, though. So import the machine module, import time, create an LED object on pin 15 as an output, infinite loop, while true, LED high, sleep for half a second, LED low, sleep for half a second. So blink your LED on and off. So that's just my main Python file, exactly like I typed in with the REPL. And now I'll use ampy, and let's do put main.py. And so that's going to put this local main.py file onto the root file system of the board here. I could put it in a different path if I wanted, like foo bar or something like that, which I think you need to make sure. I don't think the tool does, so don't do that. But if I don't put anything here, it's going to put it in the root, and that's where the main.py has to be. So I'll do that, and then it just ran. Now you see nothing really happened here because it's only when the board resets that it actually goes in and starts running your main.py. So I'm going to press the reset button, and hey, check this out. LED is blinking, and I didn't do anything. Like, I can power this thing down, and I can power it back up, and we're blinking again. So it's running my code. So that's pretty cool. And if I want, I can actually do ampy get main.py, and this is just going to download the file. And so you can see, like, that main.py file is there, and it's running the code that we expected here. So really powerful. I'm hoping that this tool kind of becomes an easy way to create like an Arduino-like workflow where you edit a file, you push it to your MicroPython board, you see if it works, you get serial output and stuff like that if you want, and then you make changes to your file, you push it out to your board, and things can work. Because right now, there's no real simple universal MicroPython IDE that's like the Arduino IDE, where you just open up this real nice little client, start typing in code. But I think we'll get there eventually. And until then, I think we can use some simple tools like this to do that. And one little note too here, you might have noticed after I ran this get command, the board locked up, it stopped, and it's not running that main script anymore. And that's just because the way this ampy tool works is it actually connects over that serial console. So it's just like when I'm running this screen command, it's connecting to this console and it's actually running the Python code to create that file or to get the file. And in order to do that, it has to terminate whatever program is running at the current time. So it just sends this break commands that say, okay, stop running, let me send the files or list the files or whatever, and then it finishes. So just be aware, it's just, that's the nature of how this tool works, that it's going to stop whatever program is running. But again, just reset the board and it's ready to go for that. So that's it. That's all I wanted to show on this stream. And really, like I said, this is the first part of the stream is really how to blink an LED. Even if you're a beginner to hardware, we just wired up a few little components and wrote like 4 lines of code maybe to blink an LED. Very, very simple and straightforward. And then this end little part here, if you didn't follow everything, don't worry. There's going to be later more tutorials on this. I just wanted to give it as a little hint of something that's coming soon that'll, I think, will make MicroPython really fun and exciting for folks. So if there are any questions, maybe throw them into the chat. And I see notes, someone's asking about PWM. Yeah, so PWM should be possible. PWM is pulse width modulation. It's like a fancy way of turning a signal on and off really fast. Like if you look at this LED, it's blinking at half a second. So it's on for half a second, off for half a second. You could speed that up a lot so that like the LED is on for like, 10 microseconds and off for like 2 microseconds. And if you look at that ratio of how long it's on versus off, then that can actually kind of modulate the intensity of the light coming from that LED. Like some devices like servos actually expect a pulse train that looks like that in order to move to certain positions. An LED, you can use a PWM signal like that to dim it. I forget the exact syntax for it, but what you want to do is look at the MicroPython board documentation, and I know I've got a link in here somewhere. If I go back to our Learn Guides here, and the basics one, let's see, let's search for MicroPython, because you're going to want to look, and maybe this is also good just to show people in general, if you do wonder, like, okay, I've used that machine module and the pin class, like what else can I do inside of there? So in the question down at the bottom here, where can I learn more about MicroPython? These are links to each of the different MicroPython boards documentation wiki, or not really wikis, but it's like the documentation that's been generated from them. Go to the documentation for your board, and unfortunately there's no universal like single MicroPython documentation source yet. Each board has their own little specific things. They're all generally very similar. They all seem to have the machine class, at least as far as I know. But just something to be aware of. You generally want to jump to your board. And then go down, let's look at the library reference. And then this goes into MicroPython specific libraries. Here's the machine module, and this is the documentation for the machine module. And it's actually pretty nice. Like it explains everything in here. So we should be able to see, like here are the classes, here's the pin class, and you can see, okay, here's where it actually tells you. This takes in, like here's the ID of the pin, and then like the type of the pin that you want to take in here, and different things that you can do with the pin class, different. Let's see, there should be like a low and a high function on here. Oh, interesting. They don't actually show the low and high function. So, hey, everything, it's all a work in progress. So MicroPython's not totally done. But anyways, to come back to PWM, they've got a PWM class. Or at least they did last I saw. Maybe it's not in the machine module. I know this documentation might be out of date. So, that's we'll come back later. So after I get through some of these basics videos, we're going to look at more of the advanced stuff. So we'll talk about PWM later, and we'll have to figure that out at that point. But it's definitely in there from what I've seen. So, and I guess worst case, if you're really advanced, you can go into the MicroPython GitHub code. And this is ultimately the true source of how MicroPython works. This is not for beginners. You don't want to look at this. This is going to confuse you a lot. But if you wanted to see like the machine module, here's the actual code for the machine module. And then if you wanted to look at like, okay, there's probably a PWM class in here. Yeah, so there's this PWM type. So you've got to go down a deep rabbit hole and kind of understand Python C extensions. But hey, if you know that, here's where to get started with that stuff. So, okay, long story short, I think that that's it. Oh, someone mentioned set up a phototransistor to detect the LED and send signals to another feather. Yeah, you could totally do that. That would be a cool idea to have boards communicating just over visible or invisible, like an infrared detector and LED. That would be a great way to send data around between different boards. And simple, because it's like you just need a digital input on both your boards. You know, if you wanted to use like a wireless radio, you've probably got to have like an I2C interface or a SPI interface that's talking to some other module and all this complexity, where it's just like, oh, you know, I just have two boards next to each other that need to send some data. Light could work. That might be a good option for that. So sound is another thing you could do too if you were interested in that. So, okay, cool. I'll wrap this up then. We'll jump back to the main view here real fast of the headshot view. And for some reason, Wirecast always glitches out on this. One day I'm going to fix this. But anyways, so I'll wrap this up. So thanks for watching. Check out youtube.com/Adafruit. You can see this video and all kinds of other fun videos and projects there. And check out twitch.tv/Adafruit. You can see me streaming these things live. I like to do at least a couple streams per week. And this month I'm doing all MicroPython related streams. So it's a really cool project. And like I said, look in the description below. You can see an introduction, like what is MicroPython video and guide. So if you don't know anything about MicroPython, start there and then kind of go to later videos like this to learn more. But yeah, check that out. And I stream on Mondays and Fridays. So this coming Monday, I'm going to do a stream on this little ampy tool that I was showing off. I'll show how to use it. And I really want to show, like, here's how to make a development workflow with MicroPython. So how to write code on your computer, how to send it to your MicroPython board, have it run that code, see what happens, and then go change your code, run it again. You know, make it a little bit easier, because right now there's not a lot of good sources of, you know, here's how to do that with MicroPython. So we'll fix that problem Monday. Tune in for that. And until then, you could look in this video and look at the GitHub repository, and there's probably enough to get you started just from that if you're familiar with some Python stuff. So anyways, Tony from Adafruit, I'll sign off. So thanks a lot for watching, and hit the like or the comment or subscribe. You know, let us know that you like this content, and we'll keep doing it. So until then, Tony from Adafruit, thanks for watching.